Welcome, honors. Let's take a look at Chapter 8, Section 3, working with geometric sequences and series. So to recap, the difference between an arithmetic sequence and a geometric sequence, we know that with an arithmetic sequence, you are adding or subtracting a common difference every time. And our graph turns out to be linear. Think back to what type of equation would make an arithmetic sequence. Well, any term, a sub n, would equal a sub 1 plus n minus 1 times our common difference. And then we know that we distribute, we simplify, we get something that fits really y equals mx plus b. Whereas a geometric sequence, you are multiplying by a common ratio. And sometimes when you see that the numbers are going down, you're like, oh, well, I'm dividing by the same amount. Yeah, you're multiplying by a fraction. Like if you multiply by a half, that's the same thing as dividing by 2. If you multiply by a third, that's the same thing as dividing by 3. Our graph becomes exponential. It's no longer linear. So that means we're going to need a different equation. We're going to have our first term, a sub 1. Then our next term is going to multiply by that common ratio. We'll call that r. Then we'll take that and we'll multiply again by our common ratio. So you have a times r, and you multiply by r again, you get a times r squared. And if we multiply that by r again, you would get ar cubed, and so on. That's how your sequence would end up looking. So let's look at this sequence here, 5, 10, 20, 40. Is it arithmetic? Is it geometric? Or it could be neither, I guess. Right? Not everything fits a sequence. Clearly not arithmetic because we're adding 5, then we're adding 10, then we're adding 20. We're adding a different amount every time. So, does it fit a geometric sequence? Well, we will take the 10, divide it by the previous term of 5, and we get 2. We'll take our 20, divide it by our previous term of 10, we get 2. So far, we have a common ratio. Ratios are fractions. Take our 40, divide it by 20, we get 2. So we're getting a common ratio of 2. In other words, you are multiplying times 2 times 2 times 2. That is indeed a geometric sequence. Our first term is 5. Let's write the explicit formula for that geometric sequence. It starts off with a sub n, just like it did with an arithmetic sequence. And then we take our first term, a sub 1, times r, our common ratio, to the exponent n minus 1. So that's your general formula for a geometric sequence. Let's fill in what we know, and we'll find the formula for this sequence that we were given. A sub n would equal our first term, 5, times our common ratio of 2 to the n minus 1. N representing the term number, so that we can find any term, like the 10th term. Now it's only the 10th term. I made it small enough so we can check it by simply multiplying by 2 until we hit the 10th term. But this gives us a way to figure out and see that our formula will actually work also. So let's start with the formula. The 10th term, we want a sub 10 equals 5 times 2 to the 10 minus 1. So a sub 10 would equal 5 times 2 to the 9th. No, you cannot multiply the 5 and the 2. They're different bases. But what we can do is figure out 2 to the 9th and multiply by 5. So in my calculator, 5 times 2 exponent 9. My answer for the 10th term is 2,560. Let's just continue our sequence and check it to make sure that we're good. So, check it, we'll continue on. First term times 2, times 2, times 2, times 2 would be 80, times 2 would be 160, 320, 640, 1280, and 2560. Term number 1, 2, 3, 4, 5, 6, 7, 8. Who do we appreciate? 9, 10. There it is. Proof. We just multiply by 2, multiply by 2, multiply by 2 every time. So what would the graph of this look like? My first term was 5. So this will be my x's, or my term numbers. These will be my answers, my y's. So I see that I'm going up to 100 here, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each of these must be 10 units. Here, looks like we're counting by ones. So over 1, up 5 would be halfway between 0 and 10. Next up, 2 and 10. 3 and 20. I can start to see the curve forming. 4 and 40. 10, 20, 30, 40. And then 5, we're up to 80. Over 5, up 190, 80 would be here. There's our curve. Exponential. Growth or decay? It is growth, yes. How about you take a minute and try, figure out if it is arithmetic, if it's geometric, find your first term, find your R or your D, write the formula, and check it. Hit pause, come on back when you're ready. Oh my, a little tougher here. So let's see, if I am looking at possibly being arithmetic, the number goes negative to positive to negative. So I would add 16 and then I would subtract something. That would not be arithmetic. You can't add 16 and then subtract 9.6 and expect to have the same difference every time. Is it geometric or is it neither? Let's take our 6 divided by negative 10. Let's take negative 3.6 divided by 6. Might want to put it in a calculator. (36) divided by 6 is 6, but there's a decimal point involved. Get it? 36 divided by 6 is 6, but there's a decimal point involved. So we have a common ratio here of negative 0.6. This is geometric. Your first term, negative 10, which lets us write our formula. Formula, a sub n equals a sub 1 times r to the n minus 1. So any term is given by the first term, negative 10, times, and I'm going to put it in parentheses since it's a decimal with a negative, negative 0.6 to the n minus 1. How can we check it? I didn't ask you yet to find a specific term number. I will, but not yet. How can we check it? Well, if our formula works and gives us the first 3 terms, then we can be fairly confident it's going to work for any term. If it just works for the first term, you can still create a different formula that would do that, and it could trick you. Even the first 2, not necessarily good enough. But having 3 in a row, the odds are most likely in your favor. Your formula is going to be correct. So I'll start off by finding a sub 1. My answer should be -10 when I plug a 1 into my calculator. -10, parentheses, -0.6, close my parentheses, exponent, 1 minus 1. 1 minus 1 is, 0, exponent 0. Get -10. For term number 2, still -10, parentheses, -0.6, parentheses, but now 2 minus 1. 2 minus 1 is 1. So change your exponent to 1, you get 6. For term number 3, everything stays the same, but now your exponent is 3 minus 1, which is 2. Change your exponent to 2, you get -3.6. So using this, can you find the 200th term? So, our 200th term, a sub 200, would equal -10 times -0.6 to the 200 minus 1. Hopefully when you put it in your calculator, you did an exponent of 199. Oh my goodness, what is that? Well, that is a huge number. 7.11375 times 10 to the -44th power. Is it a huge number? No, it's a really tiny number because of the negative exponent. Imagine taking that exponent, -44, tells you move your decimal 44 times to the left. Fill all that in with zeros. That's a very, very tiny number. How do I know it's really tiny? Well, notice that the numbers are decreasing, but they're increasing, decreasing, increasing, decreasing. But the magnitude, the 10, the 6, the 3.6, it's getting smaller every time. If I were to ignore the positives and negatives, the actual number is getting smaller. That's why this one is a tiny, 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 tiny decimal. Question to you. Since we have a negative here and a negative here, and I know that 2 negatives make a positive, can I just get rid of the negatives and make it 10 times 0.6 to the n minus 1? No, you cannot, because this negative is being raised to an exponent. So the number of negatives will change every time based upon this exponent. This part here will be positive when your exponent turns out to be even. This part here will be negative when your exponent turns out to be odd. And that's what we had here. 200 minus 1 gave us an odd exponent, so this is 199 negatives times 1 more negative. That makes a positive. Negative times 199 more negatives, 200 negatives would be an even number of negatives. If you have an even number of negatives, it's going to turn out positive. If you have an odd number of negatives, it will turn out to be negative. So no, you cannot just say a negative times a negative is a positive. This is being raised to an exponent. This is not. Found a new t-shirt for you. Dear Math, solve your own problems. I am not a therapist. Or maybe you like this one. I stopped understanding math when the alphabet got involved. Find the fifth term in each sequence, identify as arithmetic or geometrics, and find a formula. Although I guess it could be none of the above also. It might not fit any of them. You always have that possibility. Starting with the first one, 6, 9, 12, 15. What do we think? Arithmetic, geometric, or neither? Well, adding 3, adding 3, adding 3 sounds arithmetic to me. Our formula, a sub n equals a sub 1 plus n minus 1 times d. Our common difference is we're adding 3, adding 3, adding 3. A sub 1 is our first term, 6, plus n minus 1 times 3. Multiplying 3 times n, 3 times 1. So my final formula is 3n plus 3. And again, if you want to check it, you're not sure, you can always plug in n is 1, n is 2, n is 3 to get your first 3 terms. If it works for 3 of them, it's going to most likely work for the rest. So n is 1. 3 times 1 is 3, plus 3, 6. n is 2. 3 times 2 is 6, plus 3, 9. n is 3. 3 times 3 is 9, plus 3 is 12. I'm confident my formula works. Why don't you hit pause, try these out, come on back when you're ready. We'll check and see how you did. Oh, I have to find the fifth term, huh? Let me add 3. 18. Good. All right, B. 1, negative 3, 9, negative 27. The alternating signs are a clue that you've got a geometric sequence. It's never going to happen with an arithmetic sequence. You can't go positive, negative, positive, negative, positive, negative with an arithmetic sequence. Geometric, you can when there's a negative involved. So, probably going to be geometric. Let's see if we have a common ratio. Negative 3 divided by 1 is negative 3. 9 divided by negative 3 is negative 3. Negative 27 divided by 9 is negative 3. That makes that our common ratio. A sub n geometric. A sub n equals a sub 1 times r to the n minus 1. So a sub n equals 1 times negative 3 to the n minus 1. And yes, it needs to be in parentheses because it's a negative. We've seen that putting a negative in parentheses and raising it to an exponent is different than not having those parentheses and raising it to an exponent. The only thing we really don't need is the 1. So negative 3 to the n minus 1 would be my formula. The fifth term, we'll plug in 5, negative 3 to the 4th power, 81. Let me take this, multiply by negative 3, negative 27 times negative 3 would be 81. If you want to check your formula, plug in a 1, gives me exponent 0. Anything that is 0 power is 1. N is 2. 2 minus 1 would be exponent 1, and in the first power is itself. And I already checked it for the fifth term, so I'm pretty confident it works. 2, 1, 0.5, 0.25. Well, let's see, subtracting 1, subtracting a half, subtracting a fourth. That does not sound arithmetic. Is it geometric, though? Let's find out. 1 divided by 2 is 0.5. 0.5 divided by 1 is 0.5. The question remains, is 0.25 divided by 0.5 equal to 0.5 also? If you're not sure, put it in your calculator, find out. 0.25 divided by 0.5 is also 0.5. So we have a common ratio, makes this geometric. Our formula, a sub n would equal my first term, 2, times my 0.5 to the n minus 1. Plugging in 1, 2, and 3 for term number 1, term number 2, term number 3, you should be able to check and see that this formula gives you those first 3 terms. And if it does, you know you're correct. To find the fifth term, plug in 5 for n, put it in your calculator, and you're in business. 2 parentheses 0.5 exponent 5 minus 1 is 4. All right, last one. And by the way, instead of 0.5 in the parentheses, you could always use 1/2, but it would need to be in parentheses. Oh my goodness, look at this beast here. Arithmetic, geometric, I don't know. 9 to 27 would be 18. 27 to 81 would not be 18. So maybe geometric, maybe neither. Let's find out. We'll take 1 over 27. You might want to use your ABC button. Divided by 1 over 9. You might want to use your ABC button. So 1 ABC 27 divided by 1 ABC 9. That's equal to a third. 1 ABC 81 divided by 1 ABC 27. Checking for that common ratio. 1 ABC 81 divided by 1 ABC 27. That's also a third. If you think about it, the numerator, you got 1/9, 1/27, and 1 over 81. The top is being multiplied by 1, the bottom is being multiplied by 3. You're multiplying by 1/3. That's your common ratio. This is geometric. A sub n would equal our first term, 1 over 9, times our ratio of 1/3 to the n minus 1. To find your fifth term, plug a 5 in here. 1 ABC 9, putting in parentheses next. 1 ABC 3, closing my parenthesis. Exponent 5 minus 1 is 4. So a sub 5 is 1 over 729. We just multiply by 3, multiply by 3, multiply by 3, multiply by 3. The top, you multiply by 1, 1, 1, it stays the same. You and your group spend about 15 minutes working on sequences. When you get done, there is a Kahoot for you to try. You can work on your own or with a partner. If you are doing the Kahoot online, I need a name in there that I can recognize. When I go to grade it later, I'm going to be looking for your name. And if I don't know who you happen to be, I have a hard time giving you credit for that. The last thing you guys are going to do is an activity called bouncing a ball. I think you'll have a ball with this one. Let's take a look at the directions. When a ball bounces, the heights of consecutive bounces form a geometric sequence. Using several trials and measurements, you'll find a formula for the geometric sequence, and provided your measurements are accurate, that formula will be pretty good. Let's take a look at graphically what it looks like. Around the room are strips that look like this here. Each little black, white, black, white, black, white represents 1 inch. And I've marked every 10 inches off, like this is 30, this is 40, and so on. The ground would be 0. What you want to do is you want to take your tennis ball, hold it up to that strip, and let it bounce. When it rebounds, somebody in your group needs to know that height and record it for bounce number 1. Then the ball is going to keep bouncing. You're not going to catch it. You're going to let it bounce. And it's going to happen very fast. When it bounces and rebounds again, somebody else needs to get that height. When it happens a 3rd time or a 4th time, somebody needs to get those heights. It's not a bad idea if somebody records it on a cell phone in slow motion. But you didn't hear that from me. So, I've got a strip over here. I let the ball bounce. So I've got my initial height, whatever that might be. It's up to me. I'm looking at the bounces. Hopefully somebody in my group was noticing how high it went each time. If you can get that, you'll be able to fill in your formulas based upon your trials. So, you might not get 5 bounces out of it, but you should definitely get at least 3 to be able to come up with some kind of a sequence, a geometric sequence. Find the height of the bounce in inches. Find your common ratio. And then when you're done, pick any one of those trials to find the explicit formula for your geometric sequence. See you guys next time. Bye.